So we're looking at these similar triangles. So this is the kind of problem we're going to be solving. We are very concerned with how tall trees are, things like that. So similarity is kind of using proportions to kind of find missing information. So we're going to be looking at how to do that. So let's see here. Here it is. Congruence. All right, so we know what something when it's congruent. What does congruence mean? If there's two figures or three figures, however many you have, if they're congruent, they have the same shape, same size. Remember that dude with the two stools, right? These two stools are congruent, right? They're like clones of each other. Now what then is similarity? Now similarity, we have the same shape, excuse me, but the size is not necessarily the same. It might be, but it might not be. Now congruence, we use this little symbol. For similarity, we just use the little squiggle. So that's how we're going to show things are similar. So all congruent figures are similar, but not all similar figures are congruent. So let's think about that for a second. So if you're congruent, you have the same shape and same size. And if you're similar, you have the same shape. So don't all congruent figures have the same shape? So they're all similar. But if you go over here to similar triangles, they're not all the same size. So I can't say that they're congruent. So just kind of, we want to kind of keep them straight. So if something is congruent, you know it's similar. But if something is similar, you don't know if it's congruent. What else we got? Similar polygons. Corresponding angles are congruent. Okay, I'm trying to underline with my slate. Almost. But the sides are in proportion. Now remember, in congruence, we said the sides were congruent too. But not with similarity. With similarity, they have to be in proportion, which is why we've been practicing our proportions. Scale factor. Do you guys remember scale factor from like 6th grade? No? What's a scale factor? Yeah, what's a scale factor? Or smaller, right? And it's like that ratio, right, of how it compares. So when we looked in the homework, it had that map. What's the scale? So it went from 1 to 15. So it's 15 times bigger than what my drawing is showing. So a scale factor kind of tells you the proportion. So it's a common ratio of the corresponding side lengths in similar figures. So here I've got two triangles, and I see all the angles are congruent. So that's good. That means this one. So that's good. Its corresponding angles are congruent. So I'm halfway there in similarity. And then are my sides in proportion? So I look at the corresponding sides, A, B to D, E, and BC to EF, or AC to DF. Okay? What are those proportions? What are those ratios? So AB to DE is 5 to 10, BC to DE 4 to 8, 3 to 6. Now if you reduce all these, right, they're all the same value, they're 1/2. So I get the same scale factor for all the corresponding sides. That means they are all in proportion. So this means that since all the sides, the angles are congruent and all the sides are proportion, I can now conclude that the two angles are similar. You always write scale factors in the simplest form, and you really want to. It's easier to tell if you have the same scale factor if they're all in simplest form. Sometimes you can't, if you're not necessarily that good at fractions, maybe you can't tell that's all the same thing. So always reduce them. You always want to see that. So does that make sense? Right? So what's the difference between looking at proving congruence and proving similarity? When you prove congruence, all the corresponding angles are congruent, and that's true for similarity too. But in congruence, all the corresponding sides are congruent as well. Well, that's not true here, but they're all in the same proportion. So that makes the triangle similar. Basically, you take this and you enlarge it in proportion, you get that, or shrink it. So that's what a proportionate triangle is, or any polygon. That's going to be true. So let's see. So if we want to find the scale factor of this figure, these are very helpful, the little triangle notations or the angle notations, because I can see that my two polygons, these quadrilaterals, are set up kind of looking in the same direction here. So basically I want to know, well, see, what's the scale factor between corresponding sides? 20 over 16, which is what? Simplest form? 5 over 4. Then I look at 12 over 15. Well, where am I getting 12 over 15? I'm looking at these two corresponding sides. Reduce that, what do we get? What am I doing here? I went backwards. Okay. I have to go the same way. 15 goes first and then the 12. The mistake I made was I went this to this, so you need to go this to this. You're always kind of going that same direction. Divide by 3, 5 to 4. Let's look at the bottom one, 30 to 24. Divide them by 6, right? 5 to 4. And then 25 to 20. Divide by 5. So are these similar? Yes. Now what's the scale factor? 5 to 4. Now if you would have gone the other way and said 16 over 20, you could do that. And then you'd say the scale factor is 4 to 5, going from the smaller one to the bigger one, from going from the big to the small, it's 5 to 4. What else we got here? Oops. Are these figures similar? Well, how can I tell? First, let's look at the angles. Are the angles congruent? Yes, everybody's got right angles. That's good. And now I have to figure out if the sides are in proportion. Now, we have to be a little bit careful here, because are they in the same configuration here, or is somebody rotated? It certainly looks like somebody's rotated, because 6 and 6, that doesn't make sense to match those up, does it? Where's the corresponding side to say QR? Probably this guy, right? So let's see, that's 6 to 3, which is 2, and that's using these two. Now let's look at the other one. I've got 8 to 6, which is 4 to 3. Okay, so do they all have the same scale factor? So are these in proportion? Are they similar? No, they are not similar, because all the sides don't have the same scale factor. And we need that same scale factor. Alrighty? Let's see if we can find X. Now what is it telling me here? Triangle DEF, this little squiggle means is similar to triangle MNP. Find X. Well, how can we do that? What do you think? Yeah, we can do that. And since I'm already told they're similar, that means that this to this, 9 to 12, and 12 to 16, and X to 20, should all be the same number, same scale factor, right? Does it work for 9 to 12? Let's see, what's 9 to 12? Whoops, I'm all sideways, I don't know why. 3 to 4. And then, let's see, does it work for 12 to 16? Yep, 3 to 4. So what should X to 20 be? 3 to 4, right? If these are indeed similar, wow, I don't know why this is upside down. Let me try again. This slate is hard, putting that on record. For all to watch this video here. Let's see. 3 to 4? That's an X. Okay, so 4X, look at this. 4X equals 20 times 3. So what's X? 15? That's a lot of work. Just using this thing is a lot of work. So I'm using these proportions to help you find this insights question on that, because that's a lot of stuff you're going to be doing with the similarity. Yeah, okay, good. Okay. What else do we know? Perimeters and scale factors. This is kind of a cool thing. We got a theorem here. I believe we're still on page 1 here. Yeah, towards the bottom of page 1. If two polygons are similar, then the ratio of their perimeter, right? So you match up their perimeters, it's the same as the side length ratio. So that's kind of neat. So like, let me just go back for a second here. Like we had a scale factor here of 5 to 4. If you look at the perimeter of this one and the perimeter of this one, they should be in the same ratio. Can somebody do that real fast? Find the perimeter of this guy, find the perimeter of that guy. You guys are faster at adding than me. Plus you've got the calculators. So I'm going to ask somebody. Tom, you on it? You on it? Somebody's at it. Did you get any perimeters yet?
They know it's 90.
What's that? And what's this one? Is it? Is that right? Okay. Is this reduced to what I hope it reduces to? What can we divide by? Well, we start with 9, right? Oh, I can reduce that some more. Look at that. They have the same scale factor. The perimeters have the same scale factor as the sides. Now, can that be useful? So if you know the scale factor, you know the perimeter of one, You don't have to add up the other one, you can just use that ratio. I think that's cool. So let's see what I got here. So here's two polygons, A, B, C, D, E, and F. Oh, that's wrong. F, G, H, K, let me see somebody, J. F, G, H, J, K. Find the X in the perimeter of A, B, C, D, E. Okay, so how am I going to find the X? How am I going to do this? We kind of take their word for it, they're similar, right? So that means that the side ratios, let's take one of them. 10 over 15, what is that? 5 by 5? 2 to 3? Are they all 2 to 3? They should be, right? If you're going to be a similar polygon. So that means that has to be in the same ratio as x to 18. How am I getting that? X to 18, corresponding sides here. So 3x equals 36. So what's x going to be? 12? 3. Now how am I going to do this? What? How did I get that? I said that, do you see how I got 2 to 3 to be my ratio? So that means that x to 18 is also 2 to 3. That's supposed to be an x. So I did 3 times x equals 18 times 2, which is 3x equals 36, and then divide both sides by 3. Somebody add this up for me. What does that perimeter add up to? What? 69? I think that's what it is. Is that what it is? You got 70? No. So if this perimeter is 69, can I find this one? Well, again, it's going to be in the same ratio. Now, where does that 69 go? The top or the bottom? Well, let's see. The 2 and the 3, right? This is the small to the big. Small to the big. Which one do I know? The big one's perimeter. Right? That was what you were going to say, right? So that means that the small perimeter is up here. That's what my unknown is. So 3x is whatever 69 times 2 is. What is that? 170 times 2. I know that's what? What is it? 133. And then we divide by 3. 3, that's a 46. Okay. So that's the perimeter of this one. Well, look, I don't even know what all the sides are. But I know the perimeter. Look at the handy sometimes. Okay, so now let's see this guy. Okay, so we have another polygon here. I gotta get this. So I don't even have pictures, but you can always make a picture. But I know the perimeter of this one is 56. Yeah, I need pictures. I already need pictures. I can't do it without pictures. So it's some kind of quadrilateral. C, D, E, F, and G, R, S, T. This perimeter here is 56. D, E, where's that? D, E looks like 20. And R, S is 15. So these are corresponding sides. I can actually see it in the way it was made, D, E, R, S. So I can find the ratio, the scale factor. 20 over 15, which is 4 over 3? Is that right? I can't, this light's killing me, people. It's killing me. Okay, so that is the ratio of the sides. So what's the ratio of the perimeters? Same thing. So if I know the perimeter of one of them, CDEF, that's supposed to be is 56 over my unknown perimeter that I'm trying to find. So 4 times x is going to equal 56 times 3. Oh, 168, is that right? Calculator friends? 56 times 3, 168. Where'd you go? Yeah. It is, oh, okay. And then, so now I'm going to divide by 4. X equals 42. So the perimeter of this guy is 42. And I don't know all the sides. I don't even know one of them. So that's kind of neat. You can find perimeter without having to work too hard. You know those ratios, if you know the scale factor. Questions so far? Okay, good. We'll find out later if you do. Now, we know how to prove triangles congruent, right? Right? Yeah. How do you prove triangles congruent? What are our theorems for congruence? Yes.
Side to side,
Yeah.
side to side, and side angle,
Yeah.
angle to side.
Right. We got one more, right? HL? I have practice leg. Which one don't we use? Side angle or angle angle, right? I think you got them all. Right? Okay, so triangle similarity. So remember now our difference is that between congruence and similarities, angles are congruent, but sides are in proportion, right? So let's see here. Postulates and theorems. So for similarity, angle. What that says, if two angles are similar, or two triangles are similar, when any two sets of corresponding angles are congruent. Now let's think about it for a second. If you have two congruent angles, what do you really have? By the third angle congruence theorem. What?
You have third angle.
Yes, so we have three congruent angles. So if all the angles are congruent, that's enough for similarity. And if you think about like a simple example, like you have an equilateral, 60, 60, 60, 60, 60, 60, whether I blow them up, anytime you have the same angles congruent, they are similar. Possibly that they are congruent, but they're definitely similar. So I don't need to say angle, angle, angle. I only need to say angle, angle, because we already know the third angle will also be congruent in the past theorem. Side, side, side. Now that's awfully familiar, right? So when we're doing that with congruent triangles, side, side, side means all of the sides, corresponding sides are congruent. Well, what it means for proportion is all the corresponding sides are in proportion. They have the same scale factor. Same, scale factor. Excellent, okay. And we have one more side angle side. Now, in congruence, what did side angle side mean? It meant that the included angle and the two sides around that included angle, corresponding side angle sides, were congruent. Well, now what does it mean? Well, the angle is congruent, but those sides that surround that angle, that included angle, are in proportion. Same scale factor again. There's supposed to be a star for that. So let's see here. Angle similarity. Here we already talked about why you don't need all three. It's understood that if you have two angles congruent, all the angles are congruent. So let's look at this guy here, and I am on the examples here, middle-ish of page 2. Are these similar triangles? Well, let's see. These two angles are different. Well, what is that third angle? What is the third angle going to be for this guy? Yeah?
That angle, if it's congruent, it will be congruent to
But can I figure it out? What is angle K? What's its measure? How do I find this measure? Yeah, Rochelle, how do I find this measure? Yeah, add these together, subtract from 180, because all together they have to add that. So somebody do that for me. Add 85, 45, you have it ready, Andrew? What is it? 50. Oh, wait a second. So I have two angles congruent. 50, 50, 85, 85. What is this one going to be? 45. Yeah. Because if you have two, you have three. So are these similar triangles?
Yeah.
They are similar by angle, angle. And we have to kind of be careful. So triangle KLJ is similar to triangle, now we want to say it in the correct order. Z, X, Y. What do I mean by same order? Yeah.
The angle.
Yeah, like the corresponding order. So those angle measures are going to match. How about this? Do I have enough to know if I have similar triangles here, and which triangles? I'm looking at JKN, and I'm looking at the big triangle, JLN. Are they similar? Well, look at this one, angle J. Reflexive property, right? So angle J in the first one is going to be congruent to angle J in the second one. So there's an angle congruent. What do these little markers mean? Yeah?
Yeah, those two are
Parallel. So now what? Do I have any other congruent angles? No? What do you think, Natalie? JKN, KN, Y. two angles in my little triangle. So if this one's 50 and this one's 45, well, that one's 85. It looks like the same measures as the example A. So I also know this one's 50, this one's 85, so this one has to be 45. So do I have angle? Absolutely. And let's just make sure I put these in the right order. Huh? Because 50 plus 85 plus 45 is going to add up to 90. Right, so I'm adding up those triangles using that 180 degree angle thing. Triangle sum here. So let's see here. Did I do this right? 45. So S goes to 2. I did not do this right. So P matches P. And Q matches S. PQT similar to PSI. So I'm just matching up the congruent angles, so I'm doing my statement correctly. So that's one way to show similarity. Side, 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 a little bit slightly more involved here. You look for scale factors. So you kind of have to be a little bit organized, because like how do you know which goes with what, you know? So here's what I do, is I kind of say, who's the small, medium, and big side here? Like my smallest side is this one, my medium side is that one, my longest side is that one. Let's do it on all the triangles. There's the smallest, the medium, and the largest. Let's see, the smallest. And I'm just looking at the numbers. Hopefully I did it right. Sometimes I don't. So those is like the S and the S, the M and the M, and the L and the L. Those are the things that have to be in proportion, have the same scale factor. So let's look at E, F, G, and J, H, K. So now I'm looking at these two triangles. Are they similar? So let's compare long sides. So let's see. That would be 12 to 15. And let me reduce that. Divide by 3. What? Am I in the wrong way? No, I'm doing these two. I'm doing these two right here. Let's look at the medium lengths now. That would be 9 to 12. 9 to 12. Well, that's 3 to 4. It's already not right. Let me just look at the shortest, just in case I make some kind of weird mistake here. 6 to 8, which is 3 to 4. So what's going on here? I have two sides are in proportion, fantastic, but they're not in proportion with the other side. So do I have side, side, side similarity? I don't. All the scale factors have to be the same on all the sides to have that similarity. Since only two sides are in proportion, the last one isn't with it. It's not similar. All right, let's try a different one. E, F, G, and L, M, N. So I'm looking at these two right here. So let's see, the longest side on the first one there is 12, and then 20. And so let's see, what is that, 3/5? And now I'm going to look at the medium lengths. Is that a 9 to 15? And where's that coming from? 9 to 15, which is 3 to 5. Looks promising so far. These two match. Let's look at the short sides, 6 to 10. Which is 3 to 5. Do I have side, side, side similarity here?
Yes.
Yes, how come? They all have the same scale factor. When you look at the corresponding sides, they're all in the same proportion, all have the same scale factor. Let's check out these two, the last two possibilities here. So my long side, JHK first. JHK, my long side is 15. L and N, long side, 20. 15 over 20, 3 over 4. Okay, and then I look at the mediums, 12 over 15, which is, so I go to 4 over 5 already, not looking so good. Let's just do the last one for last here. 8 over 10 is 4/5. So again, I see those two sides in proportion, but not this one. So I don't have side, side, side similarity for that. So which two of these triangles are similar? These. Well, because they all have, the sides are all in that same proportion. So that makes sense what I mean by all the sides have to be in that proportion. They all have to be in that same proportion. Alrighty. The last one, side angle side, it's a similar idea. You're going to look for equal scale factors, but that included angle has to be congruent. So I've got two of them here, and it's in side angle side configuration, same like the triangles with congruent, side side angle side, it is that included angle. So let's look at the 28 and the 16 and see what the scale factor is. Divided by 4. Divided by 4. And then let's look at the shorter side, 21 to 12. And again, I'm just looking at that. Let's see, divided by 3. Excellent. So the sides are in proportion. Now, are the included angles congruent? Yes. How do I know? I'm just looking at my drawing. Because I see the one arc, that means they're congruent. So do I have a side angle side similarity here? Yes, I do. So make sense, not make sense. Okay, I go 2 thumbs up. 2 people are good. Excellent. And let's see what else we got here. This is, for some reason, this is the most important thing that we take geometry to find this out. Flagpole height. It's everywhere in geometry, but we need to know how tall that flagpole is. We do. So, okay, so on a sunny day, you're standing in front of Eagle Ridge. Look at you. Look how happy you are. Aww. All right. A friend, as one does, will measure your shadow. Well, let's see. Your shadow is 4 feet, and you are 5.5 feet, right? She also measures the flagpole shadow. 29 feet. You're standing exactly in the exact right place so that the sun will cast the shadow in exactly the same way for both of you. So do we see this little triangle here? These are going to be similar triangles if you're standing in precisely the right place, which you are. So can I find how tall this flagpole is? Yeah, how do I do that?
Find the scale factor of the small triangle.
Yeah. Well, again, these are my corresponding sides. So 4 is 29, gives me the scale factor. It's going to be the same as what? This little 5.5 dude here, over how tall the flagpole is. So you're just setting up the proportion. This is to that, and that is to that. Now when you solve for x, you are going to find out how tall that flagpole is. I can't wait. So 4x, 29 times 5.5, I've done this. I got 159.5. Does everybody agree with me? Make sure, because I make mistakes all the time. All right, how do I find x? Divide both sides by 4, and I did that. And I got, what did you get? So do we go, oh yeah, it's 39.875. No. So when it's something like this, you're almost always going to round to the nearest foot. That flagpole is about 40 feet. Isn't that awesome? We know that now. Yes, I know. She's all excited over there. That's fantastic. So if you're curious how tall the flagpole is after going to school, you can go ahead and you can do this too. I should make that a I should. I do have some practice Wednesday class that I want you to do. I took the ones, you can read these, they're a little hard to read. This one you can do. Actually, try this one. See if we can find how tall that tree is. Well, I'm just going to get out a little